right, welcome everyone to review for part 4 of the ACS exam. Let's get started. We finished with question 48, so get those notes out and ready. Make sure to continue to number them, and remember to save numbers 1 through 48, and we're actually going to reference a couple of these as we move forward. So let's go ahead and talk about question number 49. This one, you're going to have to be a little artist for a while here and draw a tiny little factory giving off some smoke and some chemical reactions up there in the clouds. So take some time to get this drawing done, and then I'll explain it once you have it all drawn out. So hit the pause and we'll see you right back here. All right, that's a nice drawing you did there. Nice detail on the mountains and the clouds. But what this is showing is how acid rain, I don't know if you caught that up there in the corner, how acid rain is formed. One of the things that factories give off a lot of is sulfur dioxide and various nitrates and nitrites. That's why this is NOx. This could be NO, it could be NO2, and even NO3. So those are the variations, and you should probably write all three of those possibilities in there. But all of them will go up and interact with water in the air and form acids. Sulfur dioxide, a very common pollutant, will form sulfuric acid. That's sulfuric acid right there. And these nitrates and nitrites, nitrogen oxide compounds, will form nitric acid. And that is not a good thing when that gets up there in the clouds, because they'll come down in the wet deposition, also known as rain, snow, and sleet, and affect the ecosystems. These types of things can dig into concrete structures, and limestone actually literally bubbles its way through there. So this is a very real problem, and question 49 deals with acid rain, and now you're somewhat of an expert on the topic. Let's move on to number 50. This is one of those where you get to press the easy button. If you have your yellow sheet and you remember, hint, yellow sheet, oxidation states can be interchanged with charge. Now, this is some common ions. When I first typed this list up a few years ago, it was called common oxidation states. So that's how interchangeable these terms are. So keep that in mind. This is a slam dunk. Take your time, yellow sheet out and at the ready, and you will get this one correct. Number 51 is Dalton's law of partial pressure. Okay, this is going to require another diagram here. So go ahead and take a little time. If you got a colored pencil or a pen, you might want to color code the blue dots and the red ovals there. So we'll see you back when you're done with this diagram. Welcome back. All right, and as you can see, with this problem, with Dalton's law, when you collect a gas over water, inevitably, you're trying to get the red ovals, which is the gas. You're trying to figure out the partial pressure of that. And what happens is inevitably water will break free and form some water vapor. Okay, so in this particular problem, I actually have a copy of the test right here. So let me check this out. They will actually give you this and give you the partial pressure of the water. Just solve for the partial pressure of the gas. So if you have that equation and this concept down, you're going to be in great shape on number 51. This is setting up pretty good, the last two problems. Here we go. Let's see what 52. Oh, are you kidding me? Boyle's law, P1V1 equals P2V2. Remember, initial conditions, this of course is pressure and volume, new conditions on the right. Plug in and solve. Take your time with the math. Don't make silly mistakes. Remember, this test is really good at putting good fake answers down. So make sure that you set that up and divide and multiply that out properly, and you should be in great shape. Now, number 53 is a bit tricky, but I'm going to do some things that are going to help you out here a little bit. This is a combined gas law problem, which is, you can see Dalton's law along the top there, and then temperature on the bottom. And what it does is it talks about sort of a unique way of setting up to solve for a new volume, like V2, for instance. And when you do this, it is very important that you get the, whether it's ones or twos, and you line those up properly. So what they did is, in this problem, they say, how would you set this up using these numbers? Well, remember, initial conditions are on the left, new conditions are on the right. And if you are rearranging this algebraically, of course, this first one here is going to be V1. But then if you look at the pressure right here, we're solving for V2. So P2, we have to drop down. That's going to be on the bottom. So if you take a time to write all of this out, you can see that P1 over P2, because here's V2, P1 is on the same level if you drop to the, go to the other side of the equal sign there, and then P2 has to drop down to the bottom. So this is, they're actually asking how you would set the numbers up. So I'm going to give you this big hint and then say, well, look, V2 is on the top here, therefore when you slide T2 over the other side, that's going to be on the top as well. So when you set this up, it's P1 over P2, and then the opposite for the temperatures. But if you have this written and you carefully plug those numbers in, that's all that question is asking for, is where do those numbers belong in a setup that looks like this. I think this one would have been pretty confusing without these hints, but with the hints, you should be in pretty good shape on this one. Okay, let's move on to number 54. Yeah, first thing you'll need for this one is a review of empirical formula versus molecular formula. All right. Remember, the empirical is simply the simplest whole number ratio of the molecular formula. So the ratio in a benzene ring, this could be, of carbon to hydrogen is 1 to 1. So these formulas are related to each other. And of course, we would add up the atomic weights going one place to the right. 12 plus 1 is 13. And don't be intimidated by the weird way that they do grams per mole. Remember, grams times mole to the -1, it means grams over moles. That -1 means drop the mole down to the bottom. That's all that means. Here you got 12 times 6 is 72, plus the 6 hydrogens at 1 each, 78 for your weight of the molecular formula versus empirical formulas. If you remember that little circle square, atomic weight calculations, that one's going to go real well for you. Okay, and that's number 54. Number 55 is a review of something that you guys, some of us got this really well and others kind of skipped over this. So this is an opportunity for you to do this. Now, you're going to predict the formula when given the percent composition. So this one was the one that we actually did in class. I just pulled up those slides again. Say you have 74% sodium, 25% oxygen roughly. What's the empirical formula? And if you'll remember, the first thing you did is, remember the little joke, and then we said, oh, no, and we had a bunch of pictures of some people in Hollywood, and then we said, no, you assume 100 grams. And if you assume 100 grams, then the percents can be converted into grams. And then you do a very simple gram to mole conversion. You look up on your periodic table, that's the atomic weight, and now you have the number of moles of sodium. Do the same thing with oxygen. It is not diatomic here. I mean, it might have a 2 behind it, but we're just talking about the pure element oxygen, not its state in nature. So just 1 O, which means that's just 16. You divide those out, you end up with 1.61. And then you said, well, that's kind of sloppy math there. I'm going to let you think about this. So how did we clean up those numbers? Real easy way to do that. That's right. Divide each by the smallest. And then you're guaranteed to have 1 to something ratio. And this would be a nice clean 1 to 2 ratio. And then you've got your empirical formula, 2 sodiums to 1 oxygen, Na2O. Okay, so you are going to be doing a similar compound. It's got 2 elements like that. It'll be very similar if you can go through those steps. And this, by the way, is one of those that you got to show the work that you at least tried this in order to earn that curve. And we've been doing a real good job of that so far. Okay, so that takes us up through number 55 and continue on the next video with number 56.